Hey guys, what's the crack? So as you know, we're adding more optional topics. We're adding medical physics. So medical physics is an optional topic in AQA, but if you're doing OCRA, you also need to know quite a lot of medical physics in your syllabus. So what we're looking at here is we're looking at someone's far point and near point, okay? So we're looking at if they're short-sighted or long-sighted. So it says a driver has a far point of 75 centimeters and a near point of 25 centimeters, right? This near point is what the near point is for a human eye, right? So the closest we can focus something is about 25 centimeters away. But your far point, the furthest you people see, should be at infinity, okay? But their far point's not infinity. So what that means is they can't see things that are far away. They can only see things that are close up. So if I can only see things that are close up, that means I am short-sighted. So it says, name the defect of vision. If someone is short-sighted, the word for that is myopia. Okay, so myopia, that's their defect of vision. It says, now complete the right diagrams to show how this vision changes. Okay, so again, we just said someone's short-sighted, so they can see things that are really close up. So remember, things that are really close up, the light rays basically spread out, and then their lens is able to focus those light rays onto the back of the retina. So they can see things really close up. But things really far away, the light rays come in parallel. Now, their lens is really good. It's really powerful. It's able to focus those light rays. So if their lens is really powerful, it's going to focus these light rays much closer in front of the retina. Because again, we said it's really powerful. So if things that are spread out, it converges onto the retina. But if they're coming in parallel, it's going to converge them really quickly. So again, here's my object, this number plate. Now, we said their lens is too strong. So what happens is when these light rays hit the cornea, first thing knows, the cornea is where most of the fraction occurs. So the light rays are going to refract. And then when it hits their lens, we just said their lens is too powerful. So what's going to happen is it's going to make those light rays converge before the retina, right? So that's why we're not able to see a clear image. They converge before the retina. So clearly they're getting converged too much. So what we need to do is we need to get these parallel light rays or something from far away. We need them to basically spread out first before they hit the cornea. And the way to get them to spread out first, before they hit the cornea or the lens, is that we can use a diverging lens. So remember, a diverging lens or a concave lens is the one that's thinner in the middle and they make the light rays spread out. So the corrective lens they're going to use here is a diverging lens. So again, I can draw it like kind of thinner in the middle, or another way we can represent it's thinner in the middle is kind of just like arrows point inwards, kind of showing you it's thinner in the middle. So what happens is when these light rays hit my diverging lens, like exactly what we just said happens, is they're going to diverge. But if you look at my picture there, that's not very good. So let's just take it back a bit so that we can actually get them to diverge and still hit the cornea. So there's my light rays coming in. There's, again, my light ray from just an object coming in. They're going to diverge.